Okay, good afternoon to everyone here. My name is Arvind Krishnan and I'm a product manager here at EMWorks. And welcome to today's webinar titled What's New in EMS 2017. Now, EMS 2017 was released last week by EMWorks, and it's probably one of the most significant releases we have had in the last couple of years. Together with working with SolidWorks 2017, EMS 2017 packs a lot of functionalities that would be of great interest to our existing users as well as our new customers. Okay. Today we shall look through most of those new functionalities here as I try to explain what they are and so on. Now let us start with the agenda for the day. We're going to start with what's new presentation. It's basically a PowerPoint format for what's new in 2017. I'm going to show you two interesting product demonstrations. The first product demonstration is geared towards some of the new users of EMS, people who have never really used our products or people who have been with us for just a few months. And the second one is a completely new product that I guess will excite a lot of you folks. Okay. Then we will talk about EMS products and applications, and finally reserve the last 10 or 15 minutes to answer any of the questions that you may have. Now we're going to use GoToMeeting for this particular webinar. So, and what that means is that whenever you have a question, please feel free to type them into the chat box of your GoToMeeting. And at the end, I will compile those questions and try and answer them. Okay, let's look at what's new in EMS 2017. We're going to start with what are the themes. We'll start with the customer portal, and we made some great enhancements to them, and we're going to be enumerating some of them. Then we're going to look at solver and meshing technology. We're going to look at result visualization. We're going to look at usability items, and finally, our newest product in the family of EMWorks is EMXpert. Now we start with the customer portal. Now we have released a new customer portal called my.emworks.com. Now all current customers and all future customers will have a login and a password where they can go into this website. Now you can use this website to renew your maintenance. You can see when your maintenance expires. You can renew them using credit card. You can download the latest software including EMS 2017. You can watch a lot of product training videos we have, and we will continuously update them. You can submit enhancements, bug reports, and any technical support issue via my.emworks.com. And you can also use support@emworks.com if you've been doing so to communicate with us, especially for your technical support. But this is another channel by which you can communicate with us, which has a history and a log and so on. Anyway, please feel free to check out my.emworks.com. If you do not have a password and the login, or if you've forgotten them, please send us an email at support@emworks.com, and we will be glad to give you your login and password. Now let us move on to the solver and meshing area. We made some significant enhancements in EMS 2017. One of the first thing is the ability to do high accuracy, or we have implemented high order tetrahedral elements for magnetostatic and AC magnetic simulation. And we have had some new algorithms for multi-core direct solvers that improves the speed of solving immensely. And now this is the new algorithm is the default multi-core direct solver. We also have added the ability for you to perform thermal stress simulation. As some of you might be knowing that EMWorks already has a coupling to thermal. You can couple electromagnetics and thermal to give you the temperature distribution. Now you can go one step further and use that temperature distribution to compute the thermal stresses in your model. So this is a completely new functionality that is available for customers who have our thermal module. Now we also have the ability to perform coupled electromagnetic and transient thermal simulations. So far, users were able to do electromagnetics and couple that with steady state thermal. Now you can couple that to transient thermal simulation. Now in the transient thermal simulation, one of the things that users want to know is how much time does it take for something to get hot. For example, when you do a steady state thermal simulation, it tells you everything about what is the final temperature distribution, but you have no idea about how long does it take for it to reach that particular temperature. Now with the transient thermal simulation, you will be able to get a sense of time and how hot your bodies get at various intervals of time. We also have made some enhancements to the coupled electromagnetic and motion simulation. We have included the ability to include initial velocities, gravity, spring, etc. And all of these will be now taken into account for simulation. And continuing the same, we have made some enhancements, especially in the form of a new simulation for the electric module. One can now do AC electric simulations. In AC electric simulations, if your voltages vary sinusoidally, now you can exploit AC electric simulation to understand the electric field distribution, the voltage distribution as a function of the phase angle. We have also made several enhancements to the parametric study. Now, in addition to all SolidWorks dimensions which could be parameterized in the earlier versions, now you have the ability to parameterize a lot of simulation parameters. For example, you can parameterize coil information, you can parameterize the frequency, etc. You can also couple thermal simulation into the parametric simulation. You can now parameterize things like the H, the heat transfer coefficient, the thermal conductivity, etc. You can also finally import parameters from a text file that we have the ability to read that, so it helps you to enter multiple parameters in one single shot. As far as the materials are concerned, we've made some significant improvements. Now we support temperature dependent BH curves. Now most BH curves is for nonlinear steels are temperature dependent. So depending on the temperature of your operation, the BH curve is going to be different. So now we enable you to enter different BH curves based on the temperature and based on the current operating temperatures of your model. You can the program will correctly select the appropriate BH curve. And in the electric module, we now compute dielectric breakdown, and we've added a new plot which is called as a safety factor plot, where you can identify regions in your model where breakdown has occurred. As far as the result visualization is concerned, we've got some new functionalities here. Now you can, when you have imported coordinates in the form of a text file, you can now read them in, and you can probe results, various results at those coordinate points. As I mentioned earlier, we have a 3D factor of safety plot to visualize dielectric breakdown. We also, for coupled motion and parametric studies, we allow you to view partially solved results in the result tables while the solver is in progress. Animation has been given some improvements. Now you can animate section plots and isoplots. You can animate section plots as a function of time, which you were always able to do. Now you can animate section plots as a function of the section position. You can also animate isoplots as a function of the ISO values. You can see how the isoplot varies as you change the ISO values. Now, EMS now allows you to overlay vectors on 3D plots. So basically, if you have a 3D plot or a section plot, now you can overlay that with vectors. You can also plot vectors on faces, and then you can plot vector plots in single color. You can maintain constant size for those vector arrows and so on. So a lot of enhancements that users have requested us have been implemented with respect to result visualization. And finally, when you want to export any kind of transient results, be it in the form of motion or a transient magnetic simulation or parametric plot, now you can export all of them to the Excel. Basically, all time steps across all scenarios in one shot, you can export it out to Excel for further processing. In addition to that, one of the important things that especially people who use cylindrical magnets have requested us is the ability to plot results in cylindrical coordinate systems. So now you can plot things like magnetic flux density, etc. in a cylindrical coordinate system. So you can get the radial, axial, and the theta component as plots, 3D plots. Users have long used our 2D plot function. Now they have the ability to define their own user-defined functions along with the 2D plot functions that well, you create the 2D plot. So if you have several 2D plots, you can now combine them. You can do a linear combination of several of these 2D plots, and you can visualize them. And finally, we have the ability to compute flux on selected faces for magnetostatic simulation. So if you have a particular cross-section and you would like to know what is the total flux going through that cross-section, you have the ability to do that now in EMS 2017. As far as the usability is concerned, we now can convert one coil type to another. For example, you defined a wound coil and you would like to make it a solid coil. You don't have to redefine. You can convert the wound coil into solid coil and vice versa. And similar holds true for the forces. For example, you had defined the Lorentz force and now you want to convert it to virtual work. You can just convert the existing force. Oftentimes, I'm not sure how often it happens for you, but it happens quite often for me that I would like to select the right face to determine the direction inside which into which my current is going inside the coil, and after I select the face and look at the symbols, I notice that I would like to reverse the face. Okay, so now you have the ability to flip the phase through which the current comes in, so one can actually reverse the direction extremely easily. Now, in the result table, we have included more visualization units. Before, it was only possible to visualize results in SI units. Now, we have included a lot more units, for example, for force, torque, etc., to visualize. Now, we've added dielectric strength as one of the property for materials inside the material browser, and this will be helpful in determining breakdown regions and breakdown voltages. The result table itself has a new look and feel. We have also made significant improvements to our material libraries. Now we have included a lot of steels from manufacturers like Carpenter, etc. And we've also included new permanent magnets inside our material library. Now, one of our newest products is called EMXpert. It's a product that we are releasing with EMS 2017. It's a new 3D motor generation software that is available now for BLDC motors, induction motors, as well as switched reluctance motors. And in the future, we will be expanding this to all kinds of motors. Now, what EMXpert allows you to do is it allows you to create fully parametric 3D SolidWorks geometry of your motors automatically. Later during this presentation, I'm going to go show you EMXpert. So this is something that is been requested by a lot of our customers who design motors and generators, and now you have the ability to create 3D models that are ready for simulation using EMXpert. Now with this, let me just go to our product demonstration here. So I'm going to start with a basic product demonstration where I will highlight a few of these what's new items as we go through them. The first one is just going to be a very simple product demonstration of how to find the force in a solenoid. Here, what I have here, I'm going to go ahead and hide the air. I have just a cross-section view of a solenoid, as you see here. There is the coil, there is the steel, and there is the top plate that is attracted. Now, the objective of this simulation is to understand what is the force with which my top plate is going to be attracted when I energize the coil. Okay. So, as usual, EMS, one can do a simulation in EMS by just going to the EMS tab. To start a simulation, we create what is known as a study. Now, here we have several different options. Now, notice AC electric, it's our newest study type that has been added. Parameterization, as I told you, allows you to parameterize many of the dimensions as well as the electromagnetic parameters like coils, etc. So you can do that. When you go to advanced properties, now I have magnetostatic simulation because I just want to understand using a DC current in the coil, what's the force of attraction on the top plate of the solenoid. Now I have a high accuracy option now in magnetostatic that allows me to solve using high order tetrahedral elements. Once I create a simulation, I can go ahead and define materials. Now, for example, I define a material. Now this is our new and expanded material library. You can see a lot more of steels being added. So I apply steel 1010. Now I can go to my recently applied materials and apply them for other materials which have the same. Now air is always a favorite material, so you can go ahead and apply air geometry. And finally, the coil is made of copper. So after applying materials, we would now go on to look at the coils and see how it is excited. And as you see here, I have just the half model done. And this is usually done in FEA is to exploit symmetry. And we're going to do that, and that reduces the size of the problem. So to enable us to do that, I'm going to go ahead back to the study properties and then look at the symmetry factor. Now I make that as 0.5, and that tells the program that I'm just simulating half of my model. Now once I do that, I'm going to now go ahead and define my coil. Now coil definition, I can go ahead and define a wound coil. I select the components that comprise the coil. I select the entry port and the exit port, and when I go ahead and show preview, I can now see what is the direction of the current through the entry and the exit. When I go to the general properties, it allows me to tell the program whether it's a current driven coil or a voltage driven coil. I have 2400 turns and 0.2 amps current passing through this coil. Now once I have my coil defined, all it is required for me to do is request the program to compute the force acting on my, so I can even select the component. Here the top plate, I would like to select that so that the program gives me the force acting on the top plate. Now with this, I can mesh and solve the problem and look at the results. Let me just quickly move on to the study that I already pre-solved before this demonstration. So let's go ahead and look at some results. Now in this particular results, as you see here, this is a plot of a 3D plot. Now I've superimposed vectors over 3D plots. So that's one of our new functionality where you can superimpose vectors on 3D plots. Okay. Now I can also do section plot. I can go ahead and do a section clipping. Now when I maybe change the here, so I can change the section. As I move here, you can see how you can look at how the vectors move across the section as well. So these are some new functionalities in the result visualization that you're going to find it useful. So I can control the density of vectors, I can control the size of vectors and so on. So this way, and I can change the color of my vectors. So a lot of improvements have been done in the result processing field. Okay. Now I'm going to go ahead and do a 2D plot. For example, let me go ahead and select a 2D plot. I'm going to just do a linear 2D plot. And I would like the program to tell me how the flux varies, say from this point in the model all the way to this point. So I select a couple of points in my model, and I would like the program to tell me how the flux varies here. So I select 20 points. So it's imported some points that I already created in SolidWorks. So I'm going to go ahead and get rid of the points that that I didn't want. So I've created 2 points in SolidWorks here, and the objective is to find out how the flux varies between these 2 points. So I'm going to make it about 40 different values I want, and I say OK. Now you can see how the flux varies between these 2 points. Okay, as a 2D plot. That was always possible, but what is new is now you can enter other kinds of functions. For example, if I want to enter just a line that is at 0.8 Tesla, okay, and now you can see that line, and you can just look at all the points that are above a particular value. What happens if you want to scale this function? So now you have a new way where you can select all the 2D plots, and maybe you want to multiply this by 5 times, and that allows you to do that. So now you can create all different kinds of plots based on your existing 2D plots. You can now add, subtract plots, functions. You can do your own user-defined functions, and you can create these things now. This is one of our new features in EMS 2017. So that's about it as far as the first demonstration is concerned. So let's get back to our objective. Our objective, in addition to computing the flux, etc., is to find the force acting. And now it gives us to a new remodeled look of the result table. As you see here, now you can find out the force acting. It's about 8 newtons attractive force acting on the top plate. Okay, so this is our new this one of this. So you can see different here. You can find out things like resistance in my coil and so on. So this is possible to do using EMS 2017. All right, so with this, I'm going to go ahead and close this and quickly jump to our newest product, which is EMXpert. Now, to be able to start EMXpert, it's an add-in product just like EMS. I'm going to go ahead and say EMProx product, EMXpert. I'm going to use the EMXpert advisor wizard to create my model of the motor. I'm going to go set next. I'm going to load the model from the library. And as I said before, EMXpert now, the first version allows you to automatically create BLDC motors, switch reluctance motors, and 3-phase induction motors. Let's use BLDC motor for this particular example. And now here is where you select the number of slots, the number of phases, obviously, we can have a three-phase motors, and we define the number of magnets that you want to do, and just say next. We have several types of stators. Let's say we would like the general round type for my stators. How do you want the rotor? The magnets are mounted on the surface of the rotor, and they're going to be radial magnets. And the stator position, is it going to be outer or inner? In this particular example, let's keep the stator as outer. Now when I say next, automatically EMXpert creates a SolidWorks model of the motor for us. Not only that, it also creates the air geometry, the inner air, the outer air, and all of that. And also we know that it's a motor, and we also create a band around which your rotating components move and so on. So it creates a model that is completely ready for simulation. And this is a parametric type of modeling, so you can change any of these equations later, and you can completely modify the geometry of your motor. Now once a basic template has been established, and then your parts and your assemblies are being created as we see here, then we will get various options how to modify your stator, rotor, your coils, your permanent magnets, and so on. So we're going to take a look at that in a few seconds once this model has been rebuilt. Okay, now once we are ready, now we can look at inspect each of the components of your motor a little bit more intimately. For example, if you don't like the skew angle in your motor and you want to change the length, your inner diameter, your outer diameter, all of those can be possible to change, and you say okay, and automatically the model rebuilds, and you get the latest geometry information in SolidWorks. Now we are going to inspect the slot. As you see here, there's a little nice diagram that tells us all this one. So anything you want to change, it's completely parametric. You can change the gap width, the tooth angle, and so on. And we're just going to go and accept the default here. Now once the stator is done, now we will go into the rotor. Now these are the windings, so we're going to accept as it is. And if there are things like the slot liners, the extension, the base inner radius, the clearance, etc., all of this can be changed. Now let's look at the rotor. Now maybe change the outer diameter to say 45, and then say okay. And finally, the permanent magnets, we have 4 of them: the thickness, the angle, the fillet radius, the offset, etc. All of them can be changed. And you say okay, and once it's done, The model is now being completely generated. The final SolidWorks assembly model, which is ready for simulation, will be generated now. Okay, there we go. And then now we can go ahead and save this as BLDC. And we are now ready to take this and do further things like create a simulation, optimize your motor, change, see how varying any parameter of your motor varies its performance, and you can take each of the parts and create an automatic drawing in SolidWorks and so on. So this EMXpert, we believe, is going to be a very handy tool for designers and engineers who work with motors and generators, and we sincerely hope that you will try this product and give us your feedback with this. Okay. That is it. Now we can go and use EMS to simulate the model. The model has been created. So in less than about 5 to 10 minutes, one can actually have a working model of your motor, the main components of your motor in SolidWorks in 3D, ready to be simulated using EMS, using EMXpert. So let me move back to my presentation and complete the rest of it. Now I want to talk to you about a little bit about EMWorks products and bundles. Now we have two different main products, which is EMS and HFWorks. Now EMS comes as EMS Professional and Premium, and HFWorks comes as just one product. Now EMS also has coupling to thermal, coupling to motion, and EMS Premium has this thermal stress feature, coupling, parameterization, and all the coupling are included in EMS Premium. We come in standard activation based license, but you can also get a network license for an additional cost if you wish to do so. As far as our high frequency products are concerned, we can do resonance, S parameters, and antennas, and they can be coupled to thermal simulation as well. The product-wise application, all the way from DC and very low frequencies all the way to a few gigahertz, we can solve using EMS and HFWorks products. The EMS products mainly focuses on electromechanical and electromagnetic type of designs. When you're thinking about solenoids, motors, generators, loudspeakers, magnet arrays, coils, transformers, bus bars, inductors, all of those are possible using the EMS products. As far as the HFWorks products are concerned, we're talking about antennas, patch antennas, horn antennas, waveguides, couplers, filters, multiplexers, and so on. And as far as the industries are concerned, we play a role all the way from automotive, transportation, defense, energy, biomedical, electronics, high-tech, and consumer goods. So it's a wide variety of industries can make use of EMS products to design their products. Now, if you're wondering, if you're a current customer on maintenance, you can go to my.emworks.com and download your latest version, which is EMS 2017. But if you are someone who's looking to get EMS 2017, or you want to get a trial version of EMS 2017, please visit our website, and there will be details as to how you can get access to our latest version. For customers who were on maintenance but currently are not on maintenance, we have a promotion going on till end of June, where the maintenance reinstatement fees of about $600 has been waived for past customers. So please contact us at sales@emworks.com, and you can get more details on it. And finally, our newest product, EMXpert. If you want to try it, we would like to preview this product to a select customers, and you can try for time of about 1 month, a free trial before you can decide to purchase. Please also contact sales@emworks.com. We advise you to put on the subject you want to try EMXpert, and we will make sure that we can reach to you the latest product EMXpert, so you can install and use it and give your feedbacks to us. Okay. Now with this, we would like to thank you all for attending today's webinar. Our website, emworks.com, has all details about our products. It also has white papers and customer testimonials. And as always, we keep expanding our YouTube channel. So if you want to see some functionalities of our product, please feel free to visit us at YouTube. This is our phone number and email address, and we'll be happy to talk to you. With this, we conclude this presentation, and now it's time for our question and answer sessions. If you have any questions, please feel free to type it down, and we'll be happy to answer them. Now, one of the questions that was asked is the EM and thermal model tightly or loosely coupled? Right now, it depends on the kind of simulation that you run. For a transient simulation, it is tightly coupled. So at the end of the transient electromagnetic simulation, we compute the thermal fields and the temperature, and then based on the new temperature values, the next magnetic simulation is conducted. For example, if your material properties vary with temperature and so on. So in that way, it is kind of tightly coupled. For steady state thermal using magnetostatic, it is loosely coupled. So there's just magnetic simulation, and the result of that is fed into the thermal simulation. So it depends on the kind of simulation that you do, whether it's loosely or tightly coupled. There's a question on what grades of magnets are available in the library. We have neodymium based magnets, samarium cobalt magnets, alnico, I guess, and yeah, these are the three primary grades of magnets. Having said that, we are, as I told you before, we've expanded these libraries quite a bit, so there's a lot more magnets added under these categories. And just wanted to let you know that EMS material library is also fully customizable. So if there are some components and magnets and materials that are missing, you can always add them and save them for future use. So the library is 100% customizable and of course expanded now. There's a question on dielectric breakdown. What is the dielectric breakdown criteria based on? Okay. Now, in electrostatic simulation, we compute the electric field throughout the model, throughout the domain of the model. Now, and whichever regions where the electric field exceeds the breakdown voltage or the dielectric strength of that particular material, then we flag those regions, and that is where you would come to know where the dielectric breakdown has occurred. So basically, it's some post-processing on the electric field plot. So you can view them as an iso plot. You can look at regions which are above the dielectric breakdown of, say, air or some other material, and it will tell you all the region. Or you can look at a safety factor plot, which is going to shade all regions where dielectric breakdown has occurred in red and everything else in another color. So if you have any more questions, please feel free to type it down. and we'll answer them. And also as a reminder, the recording of this presentation will be sent to you and to everybody who had registered for this webinar. So feel free to pass on this recording to colleagues or friends who missed this session. And because there are some very exciting things like EMXperts and also a lot of new things that people might be looking forward to. So with that, pretty much we come to an end to this webinar. On behalf of EMWorks and its staff, we thank you all for attending today's webinar, and we hope you have a nice day. Thank you very much.